Hello, this is section 3.5, part 1, and today we are going to be talking about solving exponential equations. So please get out your handout that looks like this. It says Notes 3.5 Day 1, Solving Exponential Equations, and we will get started. So to begin with, we have up here at the top a place for us to put the one-to-one property for exponential equations. It says this: for any exponential function b to the x, if b to the u is equal to b to the v, then u is equal to v. And this seems pretty self-explanatory. Anytime you raise, if you have the same base on both sides of the equation, then the exponents have to be the same as well. So that's what we're going to be doing in these first examples here. That is trying to get the same bases on both sides. So we'll try to make the bases the same, then use this one-to-one property, and then from there we'll be able to solve for the variable. So in all of these, the directions are solve for x. So let's start here with number 1. Let's see if I can make this bigger. Here we go. So we have 4 to the 5th equals 8 to the 2x plus 1 power. I want to try to make the same base on both sides. So I'm going to rewrite that 4 as 2 squared. And I'm going to rewrite the 8 as 2 cubed. And then we know that when we raise a power to a power, we just multiply the powers. So that's going to be 2 to the 10th equals, and over here, also multiply the powers, distribute that 3. So that would be 6x plus 3. Now we have the same base on both sides. So using our one-to-one property, we know that the exponents must be equal. So 10 must be equal to 6x plus 3, and then easy algebra from there. And x turns out to be 7/6, and that's our solution. Okay, and then next, over here on number 2, notice on this one, the slight difference is that we've got a coefficient here in front of the base of this exponent. So we want to start by actually dividing both sides by that. So that gives us 5 to the x over 4 power equals, and 250 divided by 2 is 125. Then we know that 125 is 5 to the 3rd power. Now we have the same base on both sides, so by the one-to-one property, the exponents are equal, and you get x to be 12. Here we are on number 3. Same deal. 32, you may recognize that as 2 to the 5th power, so 1 over 32 is 2 to the negative 5th power. 4 is, of course, 2 squared. Remember, our whole goal is to get the same base on both sides. And we've accomplished that here. Distribute the 2. Raising a power to a power means you multiply the powers. And then use the one-to-one property to set those exponents equal since their bases are equal. So we have x equals negative 11/2. And on the final one on this first page, again, this is kind of like number 2, where we have this coefficient here in front of the base of the exponent. So we need to always start by dividing both sides by that. So we're just left with, on the left, 1/3 to the x over 5 power. And on the right, 4 divided by 36 reduces to 1/9. Now, if we're trying to get the same base on both sides, I would probably just change this 1/9 to 1/3 squared. One-to-one property. Those exponents have to be equal. So we get an x value of 10. If you go over to the second page, you'll see that we are going to be solving exponential equations without the same base. If you look here on number 1, you've got a base of 4, a base of 11. There's no convenient way to write both sides using the same base. So we're going to instead solve the equation by taking a logarithm of each side. So what you do is you just say, okay, I'm going to take the log of both sides of this, and you can use whatever base you want, really. I'll just do natural log, no particular reason. Of course, you're going to want to use either natural or common log because we have those buttons on our calculator, so that makes our life easier. Once you take the log of both sides, use your power property to move this x out front and make it the coefficient. That's the whole reason why we take the log of both sides. That's to get the exponent or the variable out of the exponent. And then to solve for x, we would divide both sides by the natural log of 4. So x is the natural log of 11 divided by the natural log of 4. So then I've jumped over here to my calculator, and I'm just going to find out what that's equal to. The natural log of 11 divided by the natural log of 4. And I get a result of about 1.7297. So that would be then my answer. I don't know if you can hear my dog growling. He's mad because I'm not paying attention to him. Yes, I know. Okay, so here we go. X is about 1.7297. And that would be your result. Okay, let's go over here to number 2. Same thing's going to happen on this one. I do need to start, however, by isolating this 3 to the 2x. So I'm going to add 4. Whoops. I'm going to add 4 to both sides of that equation. So I get 3 to the 2x equals 11 plus 4, which would be 15. Can't conveniently get the same base there, so I'll take the log of both sides. This time I'll do common log, just so that you know, you can see the difference. Of course, if you do natural log of both sides, you're going to get the same answer. Take that 2x and put it out front. Power rule. And then to isolate the x, you would have to divide both sides by both 2 and log 3. Okay, so come over to the calculator, and we need to do, what are we doing here? Log of 15 divided by the quantity 2 times the log of 3. And that gives us 1.2325 approximately. So that would be our result. There you go. Okay, let's move over here to number 3. Again, you've got a base of 6 on one side, a base of 9 on the other. You can't really easily make the same base out of those, so we'll just take the log of both sides. I'll use natural log this time. Again, no particular reason for that. Move the exponent out front. And then you've got to isolate the x. So I will divide both sides by the natural log of 6. Subtract 1. And then you'll have to divide that whole thing by 3. So we're looking at this. Natural log of 9 over natural log of 6 minus 1. That whole thing divided by 3. So again, you would just put that into your calculator. I did that earlier. I got 0.0754. And there's your result. All right, so that brings us to number 4 over here. This one's going to be a little more complicated because, as you can see, we have x in an exponent on both sides of the equation. So let's look at how we would go about that. We're going to start by taking the log of both sides. Moving those exponents out front on both sides. And now, keep in mind that the natural log of 5, that's just a number. Natural log of 12, that's just a number. So you can go about this a couple of different ways. Some people like to divide both sides by the log of 5. Some people like to distribute on both sides. I think I'll do it that way. So on the left, I'll have 2 natural log 5 times x minus the natural log of 5. I just distributed that natural log of 5. Same thing over here. 3 natural log of 12 times x plus 5 times the natural log of 12. Now get all of the terms that have an x in them on the same side of the equation. So I'm going to leave the x terms on the left. And over on the right, I'll have the constant terms. I'm trying to isolate the x, so I'm going to factor an x out. And then divide both sides by this factor here. So we'd have 5 natural log 12 plus natural log 5 all over 2 natural log 5 minus 3 natural log 12. Then we just need to go to our calculators and put that in there and see what we get. So again, we've got 5 times the log of 12 plus the log of 5. That whole thing divided by 2 times the log of 5 minus 3 times the log of 12. And that gives me about negative 3.313, which would be my answer. And there we go. All right, I am going to stop this video right here, and we will do numbers 5 and 6 on the second video for this section. See you in a couple minutes.